When last we left, we were comparing extent-based allocation to fixed-size block allocation. And you might think that after that discussion, it's pretty clear that extents were better. But you'd be surprised to learn that most systems today actually use fixed block size allocation, or if they're really wild and crazy, they might have a few block sizes, 4K, 4 meg, 4 gig, and they'll build files out of those fixed size blocks. And the question is, why do they do that? So you might recall that when we compared, we said, well, what we could do is we could just pick a block size like 4 kilobytes, and then we'll just allocate files as collections of 4 kilobyte blocks. And we said there are some problems with that approach. In particular, it's going to cost us a disk address per, in the metadata per every block. So if files get really large, our metadata gets really large. And secondly, we said, if we scatter these blocks all over the disk, then performance is going to be terrible. So given all that, why do we do this? Well, it turns out that we didn't consider a few things. In particular, the POSIX standard, which is what almost all systems today adhere to, says that the way you create files is you just open files and start writing to them. That is, they grow dynamically. If you have extent-based allocation, it's really not well matched, right? How large do I create that initial extent? Who knows, right? The file could be just 10 bytes, or it could be 10 gigabytes. And you'd pick your extent size quite differently based on that. The other thing is that we have a need for what are called sparse files. So a sparse file is a file that has a hole in it, right? So the idea is, imagine that what you do is you write a byte and then you seek somewhere far in the file and then you write a byte again. So you've only got 2 bytes that are actually occupying this file. But depending on how big that seek is, the file might look like it's really huge. And you'd like to avoid allocating disk blocks for all that space in the middle. Right? The file system says that you can read from these holes in the file and you're guaranteed that we'll give you zeros. But there's no requirement that you actually allocate them on disk. And so if you tried to implement this with an extent-based system, right, these extents are big contiguous chunks, you would end up allocating disk space for these big extents, and that would be very, very wasteful. Now you might think, well, that's stupid. Why do we build files with holes in them? But it turns out that there are really important use cases where files have holes. So some of the more common ones are when you create virtual machine images, right? You create these virtual machines, and those virtual machines have virtual disks, which are make-believe disks, but those disks are huge. And a lot of times you don't fill them. And so if you didn't have sparse files, when you created these virtual machine images, you would be allocating all the space to these imaginary disks that you might never use. Similarly, if you're writing C programs, you might once in a while have experienced this thing where you have a core dump. Well, a core dump is actually a very sparse file because, as we'll learn in the next unit, the way address spaces are organized, there are actually large gaps in them. So there really are common cases where we want sparse files, and extent-based systems don't let us express those very well. So there's a key insight that makes these fixed block file systems a much better idea. And the idea is that you can decouple the notion of how we allocate blocks from where we place them on the disk. So what you can do is you can say, well, I'll allocate these blocks, but what I'm going to try to do is put them close together so that I can still get the performance as if I had implemented extents. And if I am able to do that, suddenly I can get kind of the best of both worlds. I get the flexibility that these block-based systems give us with the performance that I get when I allocate space contiguously. And so what we're going to do moving forward is look at 2 key questions, right? How do we structure metadata so that we can do this efficiently, right? How do we avoid having to store thousands and thousands of disk pointers in every file's metadata? So that's what we're going to tackle in the coming lectures. And then there's another question, which is how do we allocate these blocks so that they are in fact near each other? And the way we'll explore that is that we're going to look at some file system case studies next week and show you how some real file systems do that. So that's where we're going. Hope you have fun on the journey with us. See you soon.